Welcome to another episode of Xah Talk Show. We are going to code Wolfram Language Advent of Code 2025, Day 5, Part 2. In this month, I've done Advent of Code almost every day, so check them out. Okay, so let's begin. So the pink window shows all my command calls and keystrokes. So let me adjust it so that it doesn't get hidden. So this is my website, xahlee.info, HTTP no S. So we're gonna do advent of code, and here is advent of code. And if you are here, say hi. Leave a comment. Love to see your comment. If you are watching this offline, play at 2 speed, twice as fast. Okay. Now, xahlee.info, I have complete tutorial on Wolfram language for programmers. You can see complete tutorial, basics, common, syntax, string, data structure, list, how do you create a number, boolean, list, and how do you create a function and variable, conditional, loop. And you can download Wolfram Engine for free following this link. Okay, so let's begin code. Okay, so let's see. So let's start Wolfram language. My keyboard, let me introduce you my keyboard. This is Ultimate Hacking Keyboard 80, UHK 80. I have a video review on my website. And so here's Wolfram language, new notebook, 3 shift enter to evaluate it, and magnify. Okay, so this is Wolfram notebook. If you don't know what is Wolfram language, watch my video episode 731. That's 1 hour introduction about 3 days ago. Okay, so let's see. So Wolfram language advent of code, they okay, I forgot to put it back. Advent of code episode 734, and we can start coding. Okay, hold on a second. So I'm using Emacs, the most advanced text editor, and I'm using Sofy Keys, which is the most efficient key binding system for Emacs. So here's a source code, 4,000 lines of code. It's on GitHub, and you can go to the homepage, Sofy Keys. There are tens of video tutorials I've done in the past. Basically, it's a model key binding system like Vim, but the key mapping are based on statistics of command frequency, so it's most ergonomic. The most used commands are assigned to the most easy fingers. So can you see it? Yeah, so that's Sofy Keys, okay? And all links are here. Okay, so that's Emacs, and I'm also using a Dvorak keyboard layout, and the pink window shows all my command calls or keystrokes. Command name on the right, keystroke on the left, Dvorak keyboard layout. Showing browser, back, close, 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 showing browser. Okay, today's talk show. Now let's do day 5, part 2. Now, day 5, part 1, if you have seen yesterday or 2 days ago, that problem is given a range of numbers, 3 to 5, 10 to 14, and so on, and give a list of numbers. You want to find how many of this given list of numbers are in the range. So you want the total. Okay, that was part 1 problem. So today we are part 2. So let's see. Okay, can you see the whole thing? Okay, so part 2, the elf starts bringing their spoiled inventory to the trash chute at the back of the kitchen. so that they can start bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ingredient ID range considered to be fresh, okay? So instead of counting them, you want a list of them. An ingredient ID is still considered fresh if it is in any range, okay? Now, the second section of the database, the available ingredient IDs, is irrelevant. Here are the fresh ingredient ID ranges from the above example, okay? So for each number called ingredient ID, so do you guys understand the problem? So you see, for each number given, that each number is called ingredient ID. So if they are in this given range, any of them, that means this ID is fresh. So now, the second section of database, here are fresh ingredient ID. So you want to get a list of ranges that contains the fresh ingredient ID. 3, 4, 5, 10. Excuse me. I still have code. So if you are here, comment, okay? The ingredient IDs that are these ranges considered to be fresh are 3, 4, 5, 10, 11, 12, 13. Okay, so basically combine them, 19 and 20. 12, 13, 14, 15, 19, and 20, and 20, okay, because 20. So in this example, the fresh ingredient ID ranges consider a total of 14 ingredients ID to be fresh. Process the database file again. How many ingredient IDs are considered to be fresh according to the fresh ingredient IDs range? Okay, now you don't care about this given list of IDs. You only care about the range. Basically, you want to know, so each line specify a range, and you want to combine all the ranges. How many total number are in these ranges? Is that right? Process the database file again. How many ingredient IDs are considered to be fresh according to the fresh ingredient ID ranges? Okay, pretty simple. So the naive way to solve this problem is you just create a range of all these numbers. Then you do a union, like a set union. So you got a unique list of them. Then you just check, then you just count the length of that list, the union. Okay, that's the naive way. Now, why is that naive? Because the day 5 problem input, the ranges are huge. So if you actually generate a list of these numbers, they are gonna be millions, trillions. Let's see. So for example, copy one of them, new buffer. Let's put them into 2 line and magnify. Okay, and this number, let's put a you know, so in Python, for example, let's cut close. So let's do some testing. Okay, so in fact, let's say we can do this in Python or JavaScript or Wolfram language. Basically, you want to know, for example, let's try Wolfram language. You want comma separated. Actually, you see, in Wolfram language, it separates for you. So that's K, mega, giga, petra. So what's above giga? So let's check. kilo, kibi, mibi, GB, kilo, mega, giga. Okay, it didn't go beyond. Matrix prefix. Now we are doing excursion. We want to know what's above giga. I believe that's peta. Oh, tera. That's right. So you got giga, meg, kilo, mega, giga, then tera, peta. Okay. So what is this number? Kilo, mega, giga, tera. Tera or tetra. Tera. Okay. Tera and tera. So 221 tera. So that's 10 followed by 12 numbers, 12 zeros. That's like, so it's like 12 digits, 12 plus 13, 14, 15, 15 digit numbers. So can you have sufficient memory to actually create this large number? Let's see again. So let's kind of cheat, look at, actually this is not cheat. We just want to know how big are the numbers, the input numbers, which is part of the problem, you see. So the length, you can compare the length. They don't go over that. So that is about as large you get. Okay, so is that right? Yeah. Okay, so if we just generate a range, let's say that, okay, let's see if we'll go beyond memory. So this number to this number range, okay, let's see. Now let's look at my memory. So Wolfram language right now 195 megabyte. Okay, let's check the memory graph. Now let's do this, shift enter. General, the current computation was aborted because there was insufficient memory available to complete the computation. So yeah, so you cannot do that. That means you cannot do that in Python, in JavaScript. The number, the array length is too big. Okay, so Wolfram language simply aborted before it even computes it. Okay, so you don't want, but to find the length, it's easy. You just take the second number minus the first number. Oh, okay, so, but then you need to reduce. Okay, that's an interesting problem. You need to remove the duplicates. Okay. So how do you solve this? You see, this is, normally you just generate a range and you do a union. Very simple. But now you cannot generate a range. Interesting. So what are the comments? Hi Xah, do you notice a lot of typing difference between raw staggered keyboard like Ultimate Hacking Keyboard and Glove 80? Okay, that's a very interesting question. It turns out it doesn't matter much. Okay, let me digress on keyboard. So if you search for Xah Lee keyboard blog, you get to my keyboard blog, which is this page, and there are over 1,000 articles. So you can see 1,400 articles on keyboard, mouse, input devices, keyboard layout, trackball, and so on. So you see I got my trackball here and mouse here. So so when you shop for keyboard, there are many considerations. Do you want it split? Do you want it, can it tent, like, instead of flat it goes like that? Right now this is tented, so, and what about the key switches? Do you want it mechanical key switches? What's the difference? Does it help? Does mechanical key switches help your hand health? And if so, which one? There are so many of them, mechanical key switches. So you can find articles all here. Okay, for example, history, ergo history, key switch guide. This section is all about key switches and also keycap design. There's so many issues, and also keyboard layout, keypad key design. So keyboard layout, for example, Dvorak, Dvorak, Comac, and so on. So there are many issues to consider when you buy a keyboard, and about the relation to hand health and so on. And of course, price, portability, is it wireless or USB? What kind of wireless? Wireless USB dongle or Bluetooth? There are pros and cons. And also the weight of the keyboard, the construction, the quality, of course, and also the software. Can it remap keys? Does it have memory inside the keyboard, or do you always have to use software? So lots of consideration. Now, one of them is, let's go to key design. Okay, one of them is about the staggered. Why are keyboard's keys not aligned vertically like a grid, like a matrix? That's simple, right? Because your fingers move up, down. Your fingers, human hand is not, up and down, right? That's natural. You don't go like sideways, like the right hand goes sideways that way, the left hand, so like if you consider symmetry, if you want to go inward, then it's like, but then it's like that. Anyway, okay, my video window is too small. So anyway, why are they staggered? This way is called staggered because back then, 200 years ago, when mechanical typewriter were invented, they are mechanical. So let's go to typewriters. So I'm digressing a little bit because, to answer this question, I'm giving you a full detailed account, Palash backup, okay? So this is kind of history of mechanical typewriters. You can see elaborate ones 200 years ago, okay? So when typewriters were created, mechanical typewriters, they are mechanical. It's not electronic. So every time you press a key, they hit a hammer and so on. So they need this mechanism, you see, or this elaborate mechanism behind them. So which means the keys cannot be aligned vertically. So they are like so-called staggered or slanted. So that you see the underneath the keys, you got those levels. So they must be aligned, you see. So they have room to go to, the mechanism, the hammer bars have room. That is why the keyboard we use have this weird slanted shape. They are not like regularly orthogonal, like you think, 45 degrees. They are not like that. They are like shaped slanted in a weird way. That's because this is why. Okay, so when electronic keyboards are invented, like today, for example, let's go, when electronic keyboard, you don't have those mechanisms underneath it. The earliest one, let's see, key switch guide, ergo history, keyboard history, so when digital computers are created, okay, so where is it then? So let's open that one. For example, INVAC PK200 keyboard, 1966. There's no mechanism underneath it. It's just, electronic computers. But we human animals has a habit because we are already used to these, we are already used. Wait, by the way, this one is interesting. They are vertical. This one is kind of special. So let's go back. We are already used to this slanted way. So when people see, you know, so let me show you a vertical aligned keyboard. Okay, so let's go to ergonomic keyboard review. So you can see Glove 80, one of my favorite. You see, they are not staggered. They are just straight because your fingers move up, down. That's more natural. And lots of more. So for example, this is one of the first, you know. So these are what they call this ortholinear. Okay, so this Kinesis keyboard, Kinesis 360, I have video reviews for all of them. Okay, for this. And there's also, so this one also interesting, ortholinear, but they are symmetric. You know, they are like slanted, but they are symmetric because your hands are symmetric. It's your hand doesn't grow that way, you know. Your hand are symmetric. So when electronic keyboard got invented, people don't want it because habit, you know, they don't want this straight, you know, ortholinear because they are used to the weird slant. Okay, so that is a phenomenon of many conventions of everyday things. You know, when technology improved to have a better way, but human animals, we refuse it. We don't want it because we are already used to this weird shit. Okay, so that is why to this day, all the normal keyboards, you know, including, for example, Apple computers, you know, all the keyboards, you have this weird slant, which is idiotic, extreme. But what can you do? You know, people are used to it. Can we, oh God, let's show again. So open. So you can see Apple iBook year 2003. And this is MacBook 2019. They are all slanted. And that one is special anyway. So, so question. But today, since about 10 years ago, a lot of people, you know, we change slowly every decade when the old generation dies. The new generation, they don't know what the fuck are these mechanical typewriters, like never seen it. So they don't have this habit issue. So for the new generation, including your children, you know, whatever you get used to, you think it's best normal, but then your children don't know what your experience is. Your children think you are an idiot in many things, including programming languages. So the new generation, they don't have attachment or habit with these slanted. So beginning about 10 years ago, there are many keyboards that are, let's go, you know, they are not, they are ortholinear. For example, this one from China, ortholinear, great, okay, much better. So when you buy a keyboard today, there's a question. Should you go with the ortholinear, like the modern, supposedly better, or should you stick with the conventional, like UHK 80, which is what I'm using? So ideally, in my opinion, you should go ortholinear. Ortholinear is just better in theory and in practice. Okay, ortholinear, grid, straight, no weird slants, like complete idiotic fuck up. This habit, you know, habit induced fuck up. But however, it is not a very important issue. Okay, now let me show you some other examples. Ortholinear, you know, symmetric. Okay, that's good. That's good. But this one, you see, they do the kind of semi-traditional. So people came from traditional keyboard can get used to this, you know. So anyway, so the question is, when you buy a new keyboard, you are aware of these issues. You know, you got young, you know. So, but which one should you choose? So it turns out this ortholinear or slanted does not matter that much, all things considered. Okay, on a keyboard, you know, do you want it split? Do you want it like the surface curved? Do you want it, mechanical keys? Of course, so many choices and about keyboard layout. So of all these choices, as far as handheld goes, whether it is slanted, like the traditional slant, or whether it's ortholinear, it does not matter that much, okay? So for me, now I can use both of them trivially. I don't even notice. Like if you switch from one to the other, you might make some mistakes the first day. Then you just get used to it. Okay. So for me, like I can switch from the staggered or the ortholinear, you know, any day, any hour, no problem. Okay, does that answer your question? If I did answer your question, say yes or something. Okay, so that is a digression into keyboard. Now let's go back to coding the problem. Okay, so let me think. So we run into a problem. How do you solve this? Okay, makes sense. Fantastic. Thank you, Palash. Okay, let's solve this problem. So the problem is you are given a bunch of ranges. You want to find their union. And how many total are there? How do you solve this? Let's see. So what you can do is you okay, so you got range. First of all, you sort them by the minimum, by the first number in the range. Okay, then you break them into segments, like for example 10 to 14, 10 to 14 and 16 to 20, they overlap. How do you know they overlap? Because the first range, last number, the maximum, is, wait, they don't overlap. Hold on a second. 10 to 14, 16 to 20, okay? Now, 16 to 20 and 12 to 18, they overlap. Okay, so let me show you how that works. And let's also write it out. Okay, so we forgot. So let's not do this. Okay, so the naive way to solve this problem. So the problem, the description, problem description, given a list of ranges, for example, find how many total distinct numbers are in them. Okay, that is the problem description. Wait. Okay, problem description. Now the naive way to solve this problem is just to generate a list of numbers for each range. Then you do a set union of all the lists. Then you just count, get the length. Okay, so does that make sense? Okay, let me put this. Show in browser. So we got the problem description and we got naive solution. But the naive okay, but the naive solution won't work because the number range, too many numbers to fit into memory. Okay, that is the problem. So therefore, here better solution. Here's a better solution. Algorithm description, how we gonna attack this problem. So given a list of ranges, first we sort them. Okay, example, sort them by their mean. Okay, so press a key to sort them. Okay, actually press a key while you want to sort. So in Emacs you can do this. Give a value 1, then meta x sort numerical fields. Okay, so you sort them. So you became that. You see 12, 18 become the penultimate line, then 16, 20. You see different from here. Here is 16, 20, then 12, 18. Right? You sort them by their first number. Then you find their intersection. How do you say this? How do you say this? Let's focus on these two lines, 12 to 18, 16 to 20. They overlap. You find ranges, neighbor ranges that overlap, and you do that by to determine overlap, overlap. Check the max of two ranges overlap if the max of first, which is 18, is greater or equals to the mean of the next range. Greater or equal, yes. To the mean of the second range. Okay. Showing browser. Fantastic analysis of the problem. Anyone else watching, say hi, okay? So that's easy. Now, when you find two ranges that overlap, for example, that and that, you create a new range. Let's see. When you find the range overlap, you reduce the max of the first range by the mean of the second range minus 1. For example, 1218 becomes because 16 minus 1. Does that make sense? So 1218 becomes 1215. Then you got 16 to 20, right? Yeah. So then you can continue comparing that and the next range, okay? Does that make sense? Yes. Okay. Let's make sure this algorithm works. Okay, I think so. Does this algorithm works? So you got a list of numbers. Sort them by the first. Now, what if? Let's see. What if you have that identical? Okay, so if we follow our algorithm, this will become 12 to 11. And that doesn't work. Yeah, that's you see, this is an edge case. If they are repeated, then by our algorithm you get that. And shit. If the two ranges are identical, simply remove them. Okay, that works out. So a new rule. Before we do this, then first of all, if two ranges are identical, just remove one of them. Okay. Then what else? Let's see. What about the special case of what about special case of that? If you get that, then the new range for the first one is just 17, so that works out. Yeah. Okay. So better solution given these ranges. First, first we sort them by their mean. Then, if it so happens that two neighboring ranges are identical, remove one of them. Remove or search duplicate ranges. Okay, first step. Then you find neighboring ranges that overlap. Okay. Okay, I think that's great description analysis of the problem. We got a solution already. Now we got the algorithm. To implement it is trivial. Okay, anyone watching, say hi. Okay, to implement this is trivial. So let's go slow and have fun. I want to make this, instead of a hard-coded text, let's make it into actually paragraph instead of hard-coded. Okay, let me just show you. Okay, so problem description, given a list of ranges, code, find how many. Okay, oh god, sorry about that. Showing browser. So now that's a better description, problem description and analysis. Okay, let's start to implement this problem. Wolfram language code, solution, Wolfram language code, input. Input is just the first set of numbers. Okay. Okay, you need to turn that into a list of ranges. Okay, so we go to yesterday's input and copy the code from there. Okay. Copy, sligo, paste. Okay. This is official input, but now we only care about the first segment. So let me show you how that is done. X range list. Okay, we don't care about the wait. Okay. God, got something wrong here. That's it. Wait. Okay. Now run the whole thing. That's the result. Fantastic and beautiful. Okay. Wait, you forgot to expression. Those are actually strings. You need to expression. Okay. Copy all. Go back here. Paste it. Shift enter. Fantastic. Okay. That's the answer. You got a list of ranges. Then what you do is you do something to this range list. Okay. So according our plan, the algorithm description, we're gonna go back to today. We're gonna min max. Okay. So first of all, sort. Okay, let's do this. Let's do this in a trial and error way, so you can see the output. Then we build our function. Okay, so here's a list of ranges. Then we can actually, so let's okay, that's our list range. Okay, then what you do is you're gonna do something to that. You want to sort them. Sort. Okay, now sort takes two arguments. You can actually sort by. The difference is that sort takes a function predicate. Okay, which is a function takes two elements, then returns 1 or -1. Determine which one is from. Or you can sort by. Sort by will sort by element. Let's say first. Okay, that will do it. Okay, so let me show you. Shift enter, I believe. So you can see the difference: 16, 20, 12, 18. Now 12, 18, 6, 20. Okay, that is the sort by, the power of sort by. You can look up the documentation. Wolfram language sort by. The second argument is a function that extract the element to sort. Okay, then you just delete duplicate. Unique. Wait. Delete duplicate. Let's check the documentation. Delete duplicate data deletes all duplicates of data. Okay, we can do that. Sort by, then delete duplicate. Now in this example, well, okay, so hold on a second. Do we have a sort by? Say, let's copy the copy. So for those, it's easier to understand. Okay, now delete duplicate. What happens is that now let's say sorted ranges equals to, okay. Right, now delete duplicate will, now in our case we don't have duplicate, but let's say if there is a duplicate, let's say that. Okay, so if you do that, it will remove the 12, 18. That's repeated, you see. So this is an example. Okay, so we want to do that to the X sorted ranges. Okay, just in case. Actually, last time we checked, there's no duplicate. Okay, so delete duplicate. Okay, once you delete the duplicate, then you want to check min max. So you want to map through all of them and generate a new one. You want to check the neighbors, okay? Okay, now let me show you what to do. You want to partition. Let me show you what these do. Okay, A, B, C. Partition 2 with a repetition of 1. It will return a pair of list. Then it will return A, B, and B, C. It will return like C, D, E. Okay, I'll run it. You will see what it means. You see A, B, B, C, C, D, D, E. So it kind of partition a list with one element repetition. Okay, that's the example. Then we just map. Sorry, hold on a second. Then you just map. For example, this is a list. You map a function to this list. In here, each of the A, B, C act is a range. Okay, so for example, this A and B are two ranges. A is a range, B is a range. Okay, then you write a function to reduce that. Compare, like A, B are neighboring ranges, B and C are neighboring ranges. Hold on a second. Okay, then you write the function ff. So what the ff do? Function, then x range width, okay, 1 second. So okay, so that's the two ranges. Then what you do is if the last number of range 1, the maximum, is that algorithm, okay? If the max of the first range is greater than the first of the second range, then you return a range of okay, let's well, let's continue. Okay, then we clean the code. Okay, the first of range 1 to the last of range 2. That means they overlap. Otherwise, return simply them as is, okay? Does that make sense? Okay, so we kind of, so this code, so that's our function, okay? This, can you guys understand? If last of the first range, let's double check. If last of the first range, which is maximum, is greater than or equals to the first range 2, okay? The first of the range 2. That means they overlap. Then you return this. Otherwise, you return them as is. Actually, you can just return them as is, okay? Let's clean up the rename the variable so it's easier to understand. Shall we? Let's rename this range pair, okay? Okay, so copy that, paste it, and copy it, and paste it. So Wolfram Language formatted, it's kind of easier to understand. Okay, let's use the form, okay? So now it's easy to do. So we already, we already got the, so actually, so let me just do it, code it. We're gonna code this one shot, okay? So So these are kind of examples, okay? I mean, these are like example code telling you what it is doing, okay? Solution, okay, showing browser, problem description, and problem analysis, okay? Problem description, better solution, naive solution. Okay, problem description, naive solution. Okay, naive solution needs to move up. Then better solution, article description, and here are solution. Now here is sample code. Sample code, X-range list. You know, this is our sample solution. Just show how it works. Okay. Now we're gonna code our real solution. Okay. Now we just copy the code here. We just deleted shit. We just delete it. Yeah, so let's go back to here. Yeah, let's copy that. Copy, select all, paste. Okay, so okay, that's our range list. Okay, run it. Correct. Okay, we're gonna do this one shot. So range list, so width, okay, range list is that. Wait, what you doing? So make it one line, range list, and so here is the sample. Okay, that's the range list, and then we just do the function. So go back to today. Sort ranges. Okay, and let's copy that. Copy. So here is what we will do. Okay, so many code. So we got the range list and we want to sort them. Okay, highlight the range list. Okay, sort it. Then delete duplicate. Okay, I don't care about that. Don't care about that. When you got sorted range, that's right. Then you partition this part. Okay, partition that. Okay, partition that, then you just map a function, map the function to the list, this one. Okay, now what is the function you're gonna map? This ff, which is this function. That function. Okay, and that's it. It's clean our code. That's a solution. Okay, we can run it. Let's just run it. Okay, right. Oh yeah, you need to count the total. So wait. First normal, non-atomic. Okay, we got the issue. Non-atomic expression expected. Okay, we forgot something. Okay, so let's double check. So range list, that's right. And so this is a function mapped to this. Is that correct? Yeah, so pair, right. Then you just map. So map to this list, that's right. Then the function, here is our function. Let's be careful. Now where is x? That's where it's wrong. So x is undefined. X should be the range pair, okay? Range pair. So where is the x occur? So that's it. Run the whole code. That's right. So you got this list of unique ranges, okay? Then you just flatten. Okay, let me show you. Flatten that result. Then flatten by one level. Then you just take the length. Okay, so let me show you. Okay, so function at. Okay, what is this function? This function will flatten x by first level, then just take the length. Okay, so now it will return the solution. Run it. 6. Oh, wait, you want to know the distinct numbers. So you want to know, okay, so actually you don't want to flatten, okay? So instead of flatten, you want to, you want to flatten. Okay, then, okay, is this get complicated? You flatten, so you got a list of ranges, okay? Then you map, okay, this function, let me just write it, okay? The function will be minus, so for example, 20 minus 16 is 4. That means there are 4 of them, 16, 17, 18, 19, 20. So the last x minus first at x, then you need to plus 1. So you want to map that function to this thing. Okay, so can you guys see? Okay, so you, okay, cut, paste. Okay, this is the whole solution. I don't know if you guys will find it readable. Run it. Okay, general stop. You got a problem. Something, okay? So, well, I can see. Yeah. Yeah, so where is the problem? Run it. Non-atomic expression expected at position 1 in last 10. So you got the last 10. The flatten is wrong. So, okay, you can't do this yet. I mean, you need to see the output. Okay, so don't map yet. Okay. Let's see what's the result. So you got that result. Then let's try the flatten. That's not what you want. Okay, so you want function flatten 1. Okay. Run it. No, that's not what you want. Okay, so wait. Okay. That's why you got a problem. So instead, you want, instead of flatten, you want just flatten, okay? Do you guys find what I'm doing funny? Flatten, add, and then partition. Actually, you can do this, okay? You just need to say something like that. Yep. So flatten level 1 to -2. Jesus. Let's see, flatten, n, okay, flatten to level n. So flatten to level -2, okay? Run it. No. So let me just do this again. You don't get too complicated, okay? Flatten, so instead red, let's just put that there, okay? So flatten -2, -1. No. Should be a non-negative number. Okay, so the negative number, let's say, so if it's 1, what you get? No, so some part you don't want to flatten to 1. Yeah, so you can't use flatten on this. Yeah, okay, so you have to do partition then. Okay. Now, I'm pretty sure, wait. Okay, let me just do this in functional way, okay? Then you just say partition, flatten that all the way, then partition by 2, okay? And that should do it. Okay, that does it. Okay, that kind of that does it. So let's delete all this junk. Okay, so that is what you want to do. So you need to fix your flatten code. Yeah, so that needs to be that instead of that. Flatten at that, then you need to map that to that. Okay, so let me try something. Let's see the precedence. Okay, let's see, do I need, okay, so this is perfect. You don't need, okay, you don't need parentheses. Okay, so we just run this code. This is the solution. Okay, comment it out. This is the solution. Okay, this thing. So wait, so last minus first map to that, then you need to actually total them. Then and you need to actually total them. Put a bracket, then total. I mean, put a paren and total at, run it. 26. Now, what is that junk? Oh, yeah, because we had got this. Okay. 26, is that the solution? Consider a total of 14 ingredients ID to be fresh. 14, not 26. So I got it wrong. Yeah, annoying. Very annoying. So this code is getting too complicated. I don't think people understand. So we need to actually break them into smaller parts. But anyway, the result is wrong. That means we have to debug anyway. Oh, shit. Why is it 26? Let's see, let's run this. Nine times 9 is 18. 5, 3 is 8. So 9 times 3, 27 minus 1 is 26. That is incorrect. Okay, so okay, this is a problem. Nobody's here. Okay. Okay, so let's just run this one by one, shall we? Even that part is wrong. So what? Isn't it? Okay, that returns that. Okay, then let's just do this one by one so we don't get confused. Okay, so this map part. Copy it, go to Wolfram Language, open a new one, paste, magnify, 50, shift enter. So we get this new list. Is that correct? We separated 35. Then wait, this is like totally wrong. How did we get this? Okay, so then we need to break them apart. Range pairs. Okay, that's range pairs. Okay. That's what you get. Example. Okay. Then you map a function to this range pair. So what is the result? Great, something went missing. Okay. 3, 5, 10, 14. 3, 5, 10, 14 does not change. 10, 14, 12, 18. That became 10, 18. 10, 14, 12, 18. 10 to 14, 12 to 18. That just become 10, 18. That's correct. Now 12, 18 to 16, 20. That just becomes 12, 20. Oh, so once you do this, you need to recurse, you see. Then then you got 10, 14 and 10, 18. They overlap, so you need to recurse this tricky fuck. Okay, so you can do this once. So okay, we can modify our function so to do it one shot. No, actually we already destroyed our function. So yeah, so we need to recurse this. Okay, So once this done, then you do need to partition and flatten. Okay, then forget about that. Okay, so you need to partition and flatten, and you need to recurse this fixed point, obviously. Fixed point at this. Okay, so actually we can do it and try it. Code with one argument, two or more argument expected. That's right. You need an initial, you need a function. Oh, right, that's right. So this part, this whole thing needs to become a function. Yeah, we can do it. You know, turn this part into a function. Okay, easy. This range pair list is the input. Okay, so wait, so this range pair there, that becomes a function. You see, this is a function, and what this function do is actually up to here. Wait, this section is the function. It's kind of nesting. Okay, do you guys know what I mean? Maybe not. So Wolfram language. So okay, so you copy that. So fixed point takes a function and takes the initial value. Okay, so fixed point takes a function, cut, that's a function, then takes the initial value. So what is the initial value? That initial value is the range pair list. Okay, copy that, paste. Does that make sense? Shift enter. Ah, shit. Okay, this is taking too long. This is not good. No, nobody's watching. Okay, I'm just gonna code it quickly. Okay, I'm just gonna code it for myself and finish the problem. It's been 90 minutes already, I think. Shit. This is very interesting. Okay, this part is interesting because it shows that you need to recurse this. Because 1014, then you got 1018. In code, okay, let me just think about this. you can use block map instead of the partition, okay, instead of the flattening partition, which is much more efficient, okay. Map block map was introduced in what year? 2015, 10 years ago. Yeah, we can use that. So instead of flatten and partition by 2, we can use block map. That will save a lot of code, this partition and okay, but what is the if they overlap, then what you do? If they overlap, then now if they overlap, then first range 1, last range 2. That's right. If they do not overlap, okay, need some change of structure. Just black map. Okay. We block map this function. If they overlap, then if they overlap, then you actually need to return if they overlap 10, 14, 16, 20. Yeah, then you just return one thing, this one thing. If they do not overlap, then you actually return the first one instead of a pair, so that way you keep the structure. Do you guys understand? I don't think so. Well, you can't just return the first one because you cannot just return the first one. You need to return the pair. Well, in that case, you don't want to use block map. Let's see. You can flatten them like that. Okay. So you need to like sequence. Sequence is from 1996, yes. What? That's right. Okay, more testing. Perfect. Perfect. Wait, hold on a second. No, not perfect. 3, 5, 10, 14, 16, 20, 12, 18. No change. Oh, because you didn't sort and all that. So you need to do that first. So forget about partition then. Shit. Actually, you don't want to be pair list. Okay, just range list. That's right. Work on that. Okay, then you do this copy. No change. 10, 14, 12, 18. Why is it no change? Oh God, this is pretty bad. 10, 14. Last range 1 greater than first range 2. Then you return first range 1, last range 2. Block map. Block map is not working. Block map is not working. Oh, you need to say 2. Is that right? Yeah, stupid. That's right. The block map needs 2 here. What? Fantastic. Now wait, there's something still not right. 1620, so 1218. Wait, 1218, 1620 becomes 1220, so they get eliminated. 1014, 1218, 1014. They also need to change, but they didn't. 351014 return as is. This is incorrect. This just Splice is created in 2020. Not sure I want to use this experimental. You know, you should use splice instead of sequence there. Yeah, that's what I want, you see. That's what I want. But splice is created in 2020, 5 years ago, kind of new. So I'm not sure I want to use that. And also it says experimental. It basically removed the brackets around it. So I mean, the issue here is that you want to keep the structure so that you don't have to, every time you finish this, you have to do flatten and partition to make it pairs, to make it like that, the range. So was there a function that subset map? When is subset map created? Also pretty new, I think, 2019. Okay, I'm just gonna stick with the classic way. So this is no good because it's now taking more than an hour to solve this stupid problem. So I really need to I need to speed up. This is no good. A trivial problem. I mean, if you do the procedural way, although it's tedious, by now you would have solved it. Okay, block map. Block map. You want to keep the structure, return the same structure. So if it is overlap, then you return There's also efficiency issues you can consider. So basically, you need this step to be repeated because okay, come on, let's just solve this. Okay, so second range should be, well, one easy solution is to keep the structure. You can just like to keep the structure, just do that. And then you need to remove that 0, 1. So you can say null. Then you need to say delete null, null. Keep the structure. So you see, you got a list of ranges. So you want to merge the ranges sometimes, and otherwise leave it alone. Okay, you want to sometimes merge the ranges or leave alone. The irregularity happens when you have a pair of ranges and you merge them, become one range. So how do you solve this? So let's think about, I really want to solve this. Okay, so in a functional way, Wolfram language style. Okay, so you go to, okay, so if you don't want to use this map, block map, you could go back to recursion. Then recursion is kind of procedural, but I prefer block map. Okay. Okay, let's just do block map. Let's just do this in a way. Although it's not efficient, but like we are doing here. Okay. Flatten them all, then partition it, then that we'll do. Okay. Just get it to work. And remove the 0, 0. Okay. Wait. Paste, shift enter. Yeah. Then 10, 14, and 12, 20, they needs to be, you need to repeat this process. Okay. So what you can do is fixed point. So didn't we have that there? Yes. So we got the fixed point. And yeah, so you need to turn the whole thing into a function. function. Okay. Then the function expression is this. and the function input is range list. Okay, the function input is range list. So okay, actually they need to be there. Okay, so that will work. This function, so this function, and then you just say fixed point, fixed point. The first argument is a function, which is this one. Okay, then the second argument is the actual range list, right? Yeah, so that's the second argument. The first argument is a function. We can say ff. So make wait, so what are we doing? This is kind of advanced, pretty advanced functional programming. So let me show you. Let's just run it. Shift enter. So they reduced to 3, 5, 10, 14. 3 minus 5 minus 3 plus 1 is 3. 14 minus 10 plus 1 is 5. 5 plus 3 is 8. So is that the solution? Wait, 14. What? Wait. 3, 5, 10, 14. Wait, 12, 20 disappeared. 12, 20 disappeared. What? So this is just wrong. Jesus. Now I am now I'm really not feeling good about this because we spent so much time and did not finish it. Okay, I summon integer on lead code. So yeah, this is so bad. Let's see. Shift enter. Now copy that. Now if I put that there, so our algorithm is in fact wrong because now 12 to 20 disappeared. So 10, 14, 12, 20, do they overlap? Yes. So it should become 10, 14 to 12, 20. So it should be 10, 20. So why did this 10, 14 last first? So first range 1, last range 2, last range 2 should be 20. So how did we get 10, 14? What? We got the code just wrong somewhere, okay? So let's replace the function just by f. Oh, wait, block map. Oh, you forgot block map. It should be that. That's right. Block map by 2, then overlap 1. Oh, fucking idiotic. Okay, I have been idiotic all this time. Block map. Yeah, you forgot to say, you have to say 1 because we want 1 overlap. Okay. So, and of course, here. Okay. So now if you do fixed point, now that's good. Okay. Now if you, now, okay. So now let's suppose this is good. Delete. Delete, 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 delete. So this is our code. Perfect. Now we just yeah, we just map this to it. So let's try here. Okay, so map this to Shift Control L to copy the last output, last minus first, then total at last output. 28, which is incorrect. Oh, wait. Oh, you need to then what? Wait, hold on a second. So you need to 1018, 1020. Why is that not reduced? Oh God, now you run into another problem. Ten 18, 1020. They should become just 1020. That's right. Now if you do this again and last output, do it. That's right. Copy the last input and this part will be last output. Do it. It did not reduce. 1020, 1018. So the last maximum is greater than the first. The last first, I mean the maximum of a range is greater than the minimum of the second range. Then you merge them. So 1018, 1020 should become 1020. But it did not happen. It did not happen because why did it not happen? Let's see. 3, 5, 10, 14, 10, 14, 10, 18, 10, 18, 10, 20. Why did we not get 10, 18, 10, 20? Fact. 3, 5, 10, 14, 10, 14, 10, 18, 10, 18, 10, 20. Is that right? Yes. But then what the fuck is going on here? Oh, because what? Oh, wait, that's a function. That's a function. And okay, so this function got fed into here. So this is a function. This is the function body. Okay, and this is the argument. I'm not seeing why it is. I'm not seeing why this is not working. Oh. Yeah, this is pretty bad. So function add. You know, there's nothing. Computer, they don't make mistakes, so you always just work out diligently. There's nothing can screw you up. Okay, you can always find out what is wrong. So let's just screw this complicated nesting of functions. Let's not. you know, this part should be equivalent just to that. I cannot believe it's wait, you don't even need function here. Yeah. Now this is simpler. What I was doing before, this is simpler. Okay, run it. Wait. God, what was I doing? Let's start over again. Okay. What? God. Copy. Okay. Paste again. Now again, there is, you just simply go by logic, nothing can go wrong. Okay. So that is a function. Now you see this block is a function. Okay. Remove that function. Remove it. Okay. And this range list is now just that. Okay. Now this is again a function. So you can remove this function. Remove. And you partition block X is just that. Okay. So in other words, this is equivalent to that. So why do you do this complicated form? I'm doing this complicated form so you avoid nesting, because this is deep nesting. You get a problem when you have, so you see 3 5 10 14 10 14, so 3 5 10 14 10 14 10 18, and 10 18 10 20. So you are missing 10 18 10 20. Wait, okay, you fucked up. So why are you doing the partition shit? So your code about this flatten, what? God, this code is not good. Yeah, our block code is perfect, but this flatten and partition is screwing it up. That's right. That's right. If you are using FF, but if you are not using FF, it should work. Okay. So what the fuck is going on here? So if you just use a list, then you see 10 18 10 18 20. So then okay, where are we? Okay, let me get this to work. This is no good. This is taking too long. So taking like too long and complicated. Okay, let's try again. Range list is that. That's right. Now what's wrong with our block map? Block map produces that. Then you need to do like this. Very bad coding this session. Ten, 14, 12, 18, 12, 18, 16, 20. So what do you produce? Oh, that's right. So can you just flatten level 1? Wait. Yeah, you just flatten one level. No need to partition shit. That's right, flatten one level. No need to partition shit. Okay. So input, this is the code. Shift enter. You need to wait, we already fixed point. Why didn't it reduce? Fuck. 1014, 1018. What? This function at last output, shift enter. 1014, 1018. 1014, 1018. Why did that not combine them? So this is a problem. So X range list. Oh, wait. So fixed point function. This is. Did we have like syntax problem? Okay, no. What? That's the function. This is the input. What is original input? The original input is just that. Okay, now it went into infinite recursion. Probably Wolfram Language kernel for Windows 70 megabyte. What? 170 megabyte. Wow. Minimal use of memory. Something is wrong. There is a lot organized by name, by CPU. Wolfram Language kernel. What? Why does it run several kernels? But this is not exiting, so control period to stop, alt period, okay, alt period to abort. Yeah, very, we're not doing good today. So although the solution is very close, but it's just something is wrong. Shit, I'm gonna delete this video. Is anyone watching then? 4 people. Fuck. I'm very annoyed, So this simple problem took 2 hours and not done. And now I'm kind of tired of this thing, this functional programming, and we get into infinite loop. Something wrong with our code. Fixed point. Fixed point, a function, an expression. A function and expression. The expression is that, and the function is this function. And this function takes a range list, that's the input. Okay. Then what it do, it flattens it, it does this block map. It should work. But I don't understand why this is not work. Okay, let's try nest list. Okay, nest list of this function, and the input will be that initial input, and how many times you want to nest? 3 times. Shift enter. So here's the result. So the first time, the initial input is that. Then the first time you do it, can you do this matrix form? Table form, okay? So the first time, wait, 10, 13, 3, 5, 10, 14, 3, 5, 10, 14, 16, 20, 12, 18. That's the first time. The second time, 3, 5, 10, 14. I don't like this form. 10, 20, 16, 20, 16, 18. This is the problem. Each time you got more. You see, so each time the list increases. What? Oh, so in the step 10, 14, 10, 14. Why does the list increase? Okay, I'm tired and I'm gonna maybe delete this video because nobody's watching and it's taking 3 hours now. I think I gotta go. God. Oh, once you edit it, it becomes input. Interesting. Yeah, the list gets longer. That's just not right. Idiotic. What are these table view? No, I'm just like doing random spreadsheet. No, I'm just doing random. Okay, our code is incorrect. It's adding. Wait, is it possible for it to grow? So you map to a pair. If they overlap, you reduce the pair into one range. Okay, but now if they do not overlap, it return the pair itself. You see, but the thing is, you are doing the map, block map, so you are like almost increase the, you are mapping two neighbors. So every time you do this, you are, yeah, so you don't want to, well, yeah, that's why they increase. Now I know they increase. So what you can do is you delete duplicate. Each time you do this loop, you delete duplicate again, but that's not good. That's inefficient. So you see, that's why you got them repeated. So this, so let's see, block map. block map, block map, block map. I need to take a break. I'm not gonna finish this. I need to take a break. Okay. Very frustrated with this. What to do? Either take a break and continue, or just stop. Or stop and delete this video. Because this video, the first hour is useful because we analyze the problem. Then we went into about keyboards. But then we went over, but then, where's even my talk show page? But then we analyzed the problem very well. But then we got one code issue after another. So it doesn't look good. So delete the video. But this should work, but now I'm just tired, okay? And I'm just now tired. What to do now? Shit. I need a break for sure. Okay, break. I'm gonna come back. Maybe we'll delete this video after all, but for now, let me just take a break. Do I still live in Mountain View? Yes. Why do you ask that? Who are you? Answer, Emerson, 1. Why do you ask that question? Who are you? Okay, this fucked up. I don't feel like doing it. Now this is red wine, by the way, you cannot see. Not many, like 200 milliliters. Now, Emerson, answer the question. Who are you? Have you been watching my videos? How long ago? Like, because that's a personal question and I'm sensitive to those are kind of questions because I talk about all sort of things. Okay, answer that question. Like, why are you asking that question? Who are you? Because I don't remember, Emerson, you watched my video before. Because on the internet, there's all sort of lurkers. You don't know who they are. Don't know where you came from. Okay, anyway, so answer that question, okay? So we got this situation, this block map. Shall I explain what block map is? You know, I explain everything. It's take 10 hours. But block map allows you to map a function to a list with repetition, so you can overlap them. We want to do that because given a list of ranges, we want to check neighboring ranges. So this pair of range we want to check, then this pair of range, then next, you know, every 2 neighbors of the range. So that's why we use block map. Alternatively is you use partition, which cut a list with 1 repetition into pairs. But if you do partition, that's another call. So you map and partition. So block map combine the 2 function call into 1 function call. So block map. So if block map is given this input 35, 1014, 1620, 1218, it will produce, it will map like this: 35, 1014, 1014, 1218, 1218, 1620, and 1218, 1620. Yeah, so that's the original input list. Okay, so right now I'm just very not feeling good because I took 3 hours to work on this and it's not working. So let me just distract and go to, I need to turn on my mouse trailer because I used to have mouse trailer. I turned it off because I thought you don't need it, but actually it's better to have mouse trailer, mouse pointer trailer. So let's turn it back on. So personalization, you need to go to block, Bluetooth and devices, and mouse, and you can turn on pointing trailer. Okay, so scrolling mouse pointer speed, enhance precision, additional mouse settings there. This window 11 idiotic tiny screen. I got 30-inch screen, but they force your screen into this 2-inch. This is like extremely idiotic. This 2-inch screen mouse properties is from 1990s. So you go to pointers, you go to pointer options, then you go to display pointer trails. Now it's better, okay? Now say okay. So now I got kind of pointer trailer. So anyway, block map. Now close that. Now Emerson, did you answer the question? Very annoying. Answer the question, my friend, because I answered your question. Because if you don't answer, then I'm no more likely, I feel like deleting this video. And it's not good anyway. So block map allows you to map with overlap. So if the last range equals to, look at this part, if this if statement, if the last range, the maximum part of one range is greater or equals to the minimum of next range, then you return the pair of ranges into single range. Okay, otherwise you return the pair of ranges. So that is a problem. So this is where the ranges start to increase. That's right. So if let's think about it, A, B, B, C, right. So you want to do an extra check. If the two range is equal. Okay, so we made a progress. Fixed point. Okay, so now the code here is fairly complicated. So if okay, if range 1 is exactly equals to range 2, then just return range 1. Otherwise, then you do this, okay? That will fix it. Okay, so this function, it's getting complicated. So copy that. Actually, that should work. Okay, so just calm down and you'll solve the problem. Problem again remains. Why do you have 10, 14, 10, 18? God. What? Ten, 18, 10, 20. That should have been merged. 10, 14, 10, 18. That should have been merged. Yeah, it did some cleanup, but it got 10, 14, 10, 18. Why is it not merged? And you applied fixed point. So 10, 14, 10, 18. Is the 14 greater than 10? It is. Very annoying. Okay, Emerson is not answering the question. Very annoying. Because you asked me a question, do you still live in Mountain View? Kind of personal question. And I answered it, right? Yes, I still do. So, as a courtesy, I ask you, why do you ask that question? You should answer. And you are not answering. So that is very annoying for me, for my personality. Okay, so this function so far is just not doing the thing we want. You know, I don't know. I get let's not do the fancy trick. You see, this is not correct. I just don't understand. So this is one shot. Run it. You get that. Okay. No change. Copy that. Why is it no change? Why doesn't it change? Because 10, 14, 10, 18. If, so we got this if statement here. 10, 14, 10, 18. So why is it doesn't change? I don't understand. So if this statement, so 10, 18, 10, 20, 10, 10, 14, 10, 18. So it does work on those pair of ranges, 10, 18, 10, 20. So, but this function is not actually working. I mean, it's not actually reducing the pair. Function at fuck it. Fuck it. 10, 14, 10, 18, 10, 18, 10, 20. So Emerson 1, who are you? stupid, stupid, YouTube. It used to be you can check out their YouTube account and stuff, but okay, so let's remove that. Okay, remove that. So let's add some print statements. Right. Ten 14, 10 18, 10 18, 10 20, 10 14, 10 18, and 10 18, 10 20. That's correct. Okay, so the range pair argument is correct. Now let's print three 5 10 14, 10 14, 10 18. Right. Okay, so let's print the ranges. So 3 5 10 14. So range pair range pair 3 5 10 14, range pair 10 14, 10 18. Why is it the ranges if? Okay, so that actually, hold on a second. So that if range 1 and range 2 is equal, then do that. Otherwise range 1 and range 2 are not equal. Okay, the ranges now overlap happened. Okay, shift enter. Range pair 3, 5, 10, 14. The range is 3, 5, range 1 and range 2. Let's change the name. Range 1, 1 and 2. Okay. Range pair 3, 5, 10, 14. Range 1 and 2, 3, 5, 10, 14. Correct? Range pair, so nothing happens to there. Range pair 10, 14, 10, 18. Range 1 and 2, 10, 14, 10, 18. Correct? Overlap happened 10, 14, 10, 18. Okay? Overlap happened. So overlap happened. You should return this first range 1, last range 2. Okay? So that means 10 and 18. Oh, wait, so you got, so this, you need the commas. I mean, you need a semicolon. Do again. Range pair 3, 5, 10, 14. Range 1 and range 2, 3, 5, 10, 14. Correct? Range pair, nothing happens to those because they don't overlap. Now, range pair 10, 14, 10, 18. Okay? Range 1 and range 2, 10, 14, 10, 18. Correct? Overlap happened 10, 14 and 10, 18. Yes. Then the result is 10 to 18. Okay, 10, it didn't print. That's good. Then overlap happened. That's right. Then range pair 10, 18, 10, 20. Range 1 and 2, 10, 18, 10, 20. Overlap happened. Yes. So it returns, so overlap happened is 10, 18, 10, 20. Overlap happened. Okay. You see, overlap happened 10, 14, 10, 18. Result is 10 and 10, 18. I mean, result is 10 and 18. That's right. And here overlap happened 10, 18 and 20, 10, 20. Result is 10, 20. Oh, okay. So result is 10, 18 and result is 10, 20. So that is correct. Okay, that is correct. Three, 5, 10, 14, 10, 18, 10, 20. So this is the correct. Then we are applying this function flatten. Did this flatten not work? At last output. That's correct. Then this flatten is correct. That's what we got. So originally it was wait, what is the 10, 14, 10, 18? Wait a minute. You see 3, 5 and 10, 14, nothing happened. So they remain. Then overlap 10, 14, 10, 18. Oh, what the fuck? So when nothing happened, you should just return. You see, it didn't change nothing at all, even though our merge does work. The reason is 10.3.5, 10.14 return themselves. Then 10.14, 10.18 returns 10.18. That's right. Then 10.18, 10.20 returns 10.20. That is right. So we did merge. But however, 10.18, 10.20 become 10.20. 10.14, 10.18 becomes 10.18. However, when 3.5, 10.14 didn't change, so we discovered a fatal flaw in our algorithm, actually, a fatal flaw. That's why it didn't change. Even though some of them merged, but because you are overlapping, you are doing the block map. So can you guys see what I mean? So, so what happens is that you got this thing. So the result, even though you did merge, but the result remains the same. Amazing. Wait, so what? So the result remain the same. That's because how does this work out logically? Be sure to save this. Save, okay. I see. So it doesn't change. How does this work? How do you resolve this fatal problem logically? when you do block map, you are decreasing by one element, okay? Because you are mapping between the neighbors, but some of the results, so that these two, ten, 14. Okay, so you don't want to do block. That's right. That's right. Don't do block map. Because you are repeating. Yeah, don't do block map. Just do pairs reduce. Every time take two parts. I know what's going on. So fatal flaw with the block map. Then should we write it down? Don't overlap them. Then repeat. Okay, that is the problem. So let's merge. Let's clean up the code. Okay, so is this the code the same? Let's see. Okay, I know what to do. Don't use block map. Block map, don't do this overlap. Okay, that's why you got it wrong. But what if there is one, two, three, four, five, six, seven, eight, nine, 10. So I know what to do. That will drop the EE, which is not good. Wait, block map code two arguments, 304. Okay, so FF Emerson, still no answer. Not good. So the problem is if your range list is odd number of them, you cannot use block map. So if your range list is odd number of them, you cannot use block map, nor can you use partition. So we got a new problem. So we have to use recurse then. like nest or nest list. This is interesting. Interesting input. Yeah, so you got a list of elements. You want to merge some of them. Now you got a new insight. You got a list of ranges. Basically, you just want to merge some of them around the neighbors. Okay. Block map is a solution, but you run into this weird situation where it returns itself, basically. So these two returns that, these two returns that. Then it becomes, you see, these two, ten, 10, 18, 10, 20, 10, 14, 10, 18, 20, 10, 20. What was the original? 10, 14, 10, 18. So 10, 14, 10, 18. Oh, so you become this, you got this 10, 14, 10, 18, 10, 20. Wow, interesting. That's interesting problem. It returns itself. That is a problem. Okay, so you need you need a better solution is like recursive then. Yeah, better solution. So you start to have some kind of head and tail. So you check the first, so a function that take a list of ranges, you check the first two ranges. If they don't overlap, then you need to return kind of a list of two parts, the head and tail. In the beginning, the head is empty list. You just got the tail. Then each iteration, the function, so the function take a list of head and tail, two parts. If the head is empty, then empty. Otherwise, each iteration you take the first two ranges from the tail, see if they overlap. If they do, merge it, then put the merged result into the head, into the tail of the head, append to the head. That's it. If they do not overlap, okay, wait, hold on. So the function will take, we can write it out. So yeah, this problem is interesting. So you cannot use block. I mean, you can, but then you have to like shift you have to check even oddness of that. Okay, new argo, a function ff that takes a list of head, part, and tail. Two things: head list, tail list. Okay, head list is a list of ranges that do not overlap. Initially, it is empty. Tail list is a list of ranges to be processed. Okay. So the function of this form. Okay. The function returns a new by comparing the last item in head list with the first item in tail list. If they do not overlap, move the first item in tail list to head list. If they do overlap, merge it. Put result in head list. Okay, that's a new function. So this way, each time you will remove one range in the tail list, and each time you will grow an item in the head list until the tail list is empty. Okay, so once you do this, you repeat it. Okay, I'm tired. I don't want to implement this. Now it's 3 hours. Okay, I think I need to say goodbye. Now it's 12:20. So we've been coding this for 3 hours and got this annoying no answer that ticks me about, the privacy issues and the your followers issue. Like, you don't know who they are. And so this video has now nobody watching, so I'm gonna close it and I might delete it. Okay, bye guys.